Hello everyone and welcome to the short lecture on Amazon DynamoDB Accelerator, also referred to as DAX. So DynamoDB Accelerator or DAX offers a significant performance boost, reducing response times from milliseconds to microseconds. This is especially noticeable when handling a large volume of requests, even in the millions per second range. So one of the standout features of DAX is the ease of integration, and developers can benefit from its capabilities without need to altering their existing application logic. This is because DAX is fully compatible with the standard DynamoDB API calls. DAX is built with scalability in mind. It allows users to start with a basic 3-node cluster and, if needed, scale out to a robust 10-node cluster. This ensures that it can handle a vast range of requests, making it suitable for various application sizes. Management. DAX provides users with a high degree of flexibility. For instance, management is a breeze with DAX. It's a fully managed service, which means users do not have to get involved in tasks like provisioning hardware or software, setting up configurations, or even managing a distributed cache cluster. Next is about flexibility. So DAX provides a high degree of flexibility. For instance, it is possible to provision a single DAX cluster for multiple DynamoDB tables, or even have multiple DAX clusters for just one single DynamoDB table. Security is paramount within DAX, and it integrates seamlessly with several AWS services to bolster its security features. This includes Amazon Identity and Access Management (IAM) for controlling user access, Amazon CloudWatch for effective monitoring, and AWS CloudTrail for auditing. And furthermore, with support for Amazon VPCs, user can ensure secure access. DAX also offers tagging, which aids in better cluster visibility and management. So this is how it looks like, a high-level architecture. So it lives within a Amazon VPC network perimeter. So herein you have a DAX cluster, which is, as I talked about, it resides within a VPC, and then you have a DAX application, DAX client, which may be running on, for example, Amazon EC2, and they talk with DAX cluster, and which in turn actually talks with Amazon DynamoDB. So your DAX client don't have to change your application code, because those API calls are compatible with DAX cluster. So it will just go through DAX cluster, and then which will be offering much higher performance compared to directly if you talk to Amazon DynamoDB. So DAX offers access to data from DynamoDB with an impressive microsecond latency, ensuring rapid data retrieval. High efficiency. So a multi-AZ DAX cluster is highly efficient, capable of serving millions of requests every second, catering to high demand scenarios. DAX is particularly beneficial for applications that demand the quickest response time for read operations. These includes real-time bidding, for example, bidding platforms, social gaming interfaces, and trading applications where speed is paramount. High demand scenarios. So some applications frequently read specific items more than others. For instance, during a one-day sale of a trending product in an e-commerce system, the demand for that product's data would spike. DAX helps in such scenarios by offloading the read activity to its cache, ensuring smooth operations during such high demand periods. For applications that have a high volume of read operations but are also budget conscious, DAX offers a solution. Instead of increasing the provision read throughput in DynamoDB, which incurs additional cost, one can divert the read activity to a DAX cluster, and this approach can lead to cost savings, as there is a reduction in the number of read capacity units purchased. A large dataset reads. So in situations where there is a need for repeated reads against a vast dataset, DAX proves invaluable. For instance, a comprehensive analysis of a regional weather data might consume all the read capacity of a DynamoDB table, affecting other applications accessing the same data. So DAX allows such analysis to be conducted on a cache data, ensuring other applications remain unaffected. So data DAX request processing. So I'll talk something about request processing within DAX. So a DAX cluster is made up of multiple nodes, and with each node operating its own instance of the DAX caching software. Within the DAX cluster, one of the primary nodes is designated as the primary node. One of the nodes is designated as primary node, and if there are additional nodes, they act as read replicas, enhancing their read capacity. Interacting with DAX. To interact with DAX, application utilize the specific endpoint for the DAX cluster. This endpoint acts as the gateway for all requests and interactions. The DAX client software plays a crucial role in ensuring efficient operations. It collaborates with the cluster endpoint to execute intelligent load balancing and effective routing of requests. So DAX, something about DAX read operations. DAX is equipped to handle specific API calls, namely get item, batch get item, query, and scan. These calls are essential for retrieving the data. By default, DAX operates with eventually consistent reads. This means that it tries to fetch the requested item from its cache before resorting to DynamoDB. When DAX has requested item in its cache, it is termed as a cache hit. In this scenario, DAX returns the item directly to the application without needing to access DynamoDB. On the other hand, if DAX does not have an item, which is called a cache miss, it forwards the request to DynamoDB. When DAX gets the response from DynamoDB, it not only returns the result to the application but also stores it in the cache on its primary node for future request. So we have a cache hit. So for example, your applications are trying to hit a DAX cluster. If the item is there, it has been retrieved before, so it will be there in the cache in the DAX cluster. It will return back to the application directly, so it will not consult the DynamoDB table. But if the item is not there in the DAX cluster, this will be called a cache miss because it's not there in the cache. It will go to the DynamoDB, fetch the item, store in the DAX cluster also, and return to the application. So if it is queried against, it will be found in the DAX cluster and it will be cache hit again. So something about DAX write operations. So it supports all the API operations like batch write item, update item, delete item, put item, and write process. So initially it will write to the DynamoDB and subsequent write to the DAX cluster. So first it will write to DynamoDB and then finally subsequently it will write to DAX cluster next. So it must succeed both the places for write process to be successful. And success criteria: data in both DynamoDB and DAX cluster. And that's all. Thanks for watching.